Okay, welcome back to another video. This is Yaula from VANTAGE TUTOR, a class above the rest. Now today we're going to take a look at a question from St Andrews Junior College, year 2020, paper 3, question 3E. Alright, now this is a mixture of organic chemistry and your reaction kinetics. Alright, so in this question we're going to see in the first part, we're going to need to do a simple chemical test. Basically, it's your distinguishing test. Subsequently, we talk about your reaction kinetics in terms of first order, how to sketch the graph, how to do an experiment. Okay, so if you're watching this on TikTok, I'm only going to go through E part 1 to keep the video short. Okay, and if you're interested to finish the question with me, which is part 2 and 3 on reaction kinetics, you can of course see it on YouTube for the rest of the video. Alright, so if you're ready, we can now get started. Now let's look at this question, phenylaniline. Okay, this is a carboxylic acid, so even though this is not very relevant to what I'm talking about today, carboxylic acid basically is this carbon in green right here. On the left is some carboxylic acid, on the right is some amine, hence the amino acid name. Okay, so this is a form of your amino acid, phenylaniline. Don't need to memorize, I think there's like 20 of them. Okay, so this question basically is asking for, suggest a simple chemical test to detect the presence of tyrosine and state the observation that you would expect. Now, in this question, I think a lot of you, right off the bat, you can tell that you're looking for a difference in the functional group. So between these two molecules, I think the most outstanding functional group is right here. The fact that this has a phenol, whereas your phenylaniline does not have a benzene ring with a OH group. So a lot of you will straight away jump because you all memorize all your notes, right? You all know all your distinguishing tests at the back of your fingertips or back of your hand, whatever it is. Okay, and you just tell me that the answer is FeCl3, and then you do your discoloration and all that, and you are right. Okay, but if you are my student, especially the 4 of you who are listening in from EJ, you know that I'm a simple man. My former students know as well. Essentially, I only always use like maybe 3 or 4 distinguishing tests. Okay, so I'm not a guy who like to memorize the FeCl3 thing, because to be honest, I think I used that answer less than 5 times in my entire life and I've taken a chemistry degree. Okay, so in this question, my answer is very simply, because of the phenol, I'm just going to do Br2 aqueous. And my answer is just that the Br2 aqueous from orange to colorless or reddish brown to colorless or decolorization of your reddish brown solution. Okay, so this video is going to be very short. My point of this video is just to tell you that your distinguishing test don't need to think so complicated. There's only a few of them. Effectively, most of the time you can use your Br2 aqueous in most of your questions. If not, some other reagent condition, maybe KMNO4. I've already given you 2 of my 4 distinguishing tests. Okay, so just for the sake of completion, let's finish the question. So number 1, how do I write this down? So number 1, my test is gonna be Br2 aqueous. Okay, and then my observation. Okay, for me, I always write before and after. So I always write something like reddish brown solution turns colorless. Okay, so for the rest of you, I think you're going to talk about your FeCl3. If I'm not wrong, it's purple coloration or decolorization. Honestly, I don't really care because I don't really use that test. Most of the time, your distinguishing test is only looking for a color change in not effervescence. In this case, I think the easiest distinguishing test is just Br2 aqueous. Okay, and that's the end of the question for part 1. Again, if you're keen to see how I solve part 2 and 3, feel free to go on to my YouTube and watch me finish the video. Take care. This is Yaula from VANTAGE TUTOR, a class above the rest. Okay, welcome back to the second part of the video. For those who came here from TikTok, good to see you here. So just a reminder, this is a question from St Andrews Junior College, 2020 paper 3, question 3E. Now I've already done the first part, which is your distinguishing test. between your phenylalanin and your tyrosine. So we're now going to do part 2, which I promise, okay, is actually your reaction kinetics. Okay, so let's have a closer look at this question. Okay, sketch the graph of the rate of reaction against the rate against the concentration of phenylalanin. And they told you that in this equation is actually a first order. Okay, so now you know that it's a first order reaction. You're looking for the rate against the concentration. Okay, so let's plot the axis first. Okay, let's play with this a bit, you know. Down, oh shit. Okay. So now I know that this is rate against concentration. So concentration of phenylalanin. And then this is my rate. Okay, so I'm looking for a first order reaction. That means now phenylalanin, okay, as my concentration of phenylalanin increases, my rate increases proportionately. And most importantly, it must pass through the origin. Okay, so now knowing this, I know that it's proportionate. Okay, it's not exponential increase, not exponential decrease, whatever it is, or the concentration does not remain constant. I know that it's going to be a straight line passing through the origin. And this is my answer for part 2. Okay, now second part, use your answer in E part 1, outline a suitable experiment. Okay, a suitable experiment for obtaining the graph in E part 2. Okay, now this is very similar to your planning, but if I look at the marks, it's only 3 marks, so I'm going to give them too much detail and waste my time. So in the concern of time, I probably have to write something very brief. Okay, now the main concern with this question is, a lot of students, they realize that this is a first order reaction. Sure, we just think of the first thing, right? You and I both know, the first thing I think about, oh, constant half-life. But because this question, if you look carefully at part 3, they say using your answer in E part 1, outline a suitable experiment for obtaining the graph in E part 2. Now your graph in E part 2 is rate against concentration. Whereas if you talk about your half-life, it's always your concentration, okay, concentration versus your time. And therefore, your experiment should not revolve around plotting a graph of your concentration against time and therefore measuring your half-life and ensuring that your half-life is constant. That is not the question. And therefore this question is actually, to me, simpler than most students would expect. Okay, so in this question I just need to show that I have a concentration increasing and my rate increases at a linear relationship, right? So basically all they're asking for is just, you know, wait 1 second. You just need to give me how to get this point, how to get this point, how to get this point, how to get this point. Okay, so generally I want about 4 to 5 points on the line. So how do I prepare this? Alright, so firstly I need to prepare 4 solutions of your phenylalanin at different known concentrations. Okay, why is it different known concentration? Again, you look back at your graph, you're trying to get this point, this point, this point, this point, right? So this is so-called, you learn in Set 1, your independent variable. Okay, now to get your y coordinates, which is your rate, that's obviously what you're trying to measure, right? But how do I measure the rate? How do I tell that how much of my phenylalanin, or rather, how much of my phenylalanin has reacted away, right? So this is where I link back to my part 1, which is that I know that my phenylalanin changes to tyrosine in this breakdown. So as long as I know how much tyrosine is present, or rather the moment it changes, it fully reacts to become tyrosine, I can more or less know that, oh, my phenylalanin has reacted away. So in other words, this experiment revolves around your simple chemical test. Okay, so again, let me remind you, you're trying to find out when it becomes tyrosine. The moment it has become tyrosine, that means your phenylalanin has broken down, and therefore that is actually your rate of reaction. Okay, so now going back here, okay, so now let's go to point number 2. So that's point 1. Point 1. Point 2, all you have to do is to each sample add a fixed known amount of Br2. Okay, for me I'm using Br2. Of course you can use your FeCl3, and then subsequently I just need to measure time taken for decolorization of my reddish brown solution. Okay, then subsequently the last part is just basically measuring your rate. So rate is equals to 1 over time taken, which is actually something given in the question already. Okay, it's right here. Okay, so that's the end of this question. If you enjoy what I'm doing, give me a follow, give me a like, or subscribe to my YouTube channel. I'm trying to reach 1,000 followers on TikTok and however many subscribers on YouTube, so that I can do a live video of me just solving question after question after question. You will get an access to my thought process, and then hopefully you learn something from it. Okay, so this is the end of the video. This is Yao from VANTAGE Tutor.